Alright, so in this video, I'm going to be solving the equation x to the power of x is equal to x to the power of 2. So, my only variable in this equation is x, so that's obviously the variable which I'm going to be solving for. And now for my solution. I'm going to first write my equation down here. So I have x to the power of x is equal to x to the power of 2. And I'm going to first start by dividing both sides by x to the power of 2. So I have x to the power of x over x to the power of 2 is equal to x to the power of 2 over x to the power of 2. And x to the power of 2, x to the power of 2, these two cancel out. So now I'm going to be left with x to the power of x over x to the power of 2 is equal to 1. Now from here, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So x to the power of x over x to the power of 2 is going to equal x to the power of x minus 2, which is equal to 1. Now I can take the ln or natural log on both sides. So I have ln x to the power of x minus 2 is equal to ln of 1. Now, an important property of logarithms is that if I have something in the form ln a to the power of b, I can move this exponent b to the front. So this can equal b times ln a. And this property is very useful because notice how now x is an exponent, and in this state it's really hard to solve for x. But now, using this property, I can move it to the front, and now it's an actual term and it's much easier to solve for it. So I get x minus 2 times ln x is equal to ln 1, and ln of 1 is the same thing as 0. So I have x minus 2 times ln x is equal to 0. Now from here, I get two equations. I get x minus 2 is equal to 0, and I also have ln of x is equal to 0, meaning 2 equals 0. And all I have to do to solve this is to add 2 on both sides. So then these two cancel out, and I'm left with x is equal to 0 plus 2, which is 2. Now, for my second equation, I have ln of x equals 0. And this is basically asking ln of what is equal to 0. And, well, we already know ln of 1 is equal to 0, but what if we didn't know this? Well, what we can do is take e to the power of both sides. So I have e to the power of ln x is equal to e to the power of 0. And e and ln, these two cancel out. So I get x is equal to e to the power of 0, which is 1. So now that I have two solutions for x, what I'm going to do is check to see if these are right. So my equation is x to the power of x is equal to x to the power of 2. And let's first start by checking 1. So if x equals 1, I have 1 to the power of 1 is equal to 1 to the power of 2. 1 to the power of 1 is 1, and 1 to the power of 2 is also 1, so this is right. And now I'm going to check x equals 2. So I have 2 to the power of 2 is equal to 2 to the power of 2. 2 to the power of 2 is 4, so I get 4 equals 4, and this is right as well. Alright, so in this video, I'm going to be solving the problem 2 to the power of 20 minus 1. So I want to find the value of 2 to the power of 20 minus 1. So to solve this, what I'm first going to do is I'm going to rewrite 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 10 times 2 is equal to 2 to the power of 10 to the power of 2. And I have this minus 1. Now 1 I can rewrite as 1 squared because 1 is the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 squared. And the reason I put this in this form is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10 and b is equal to 1. So now I get 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now, 2 to the power of 10 is equal to 2 to the power of 5 plus 5, which is equal to 2 to the power of 5 times 2 to the power of 5, which is equal to 32 times 32, and 32 times 32 is 1024. So I get 1024 plus 1 times 1024 minus 1. Now 1024 plus 1 is 1025, and 1024 minus 1 is 1023. So now I have 1025 times 1023, and to solve this, or to multiply these two, I'm not just going to do it using the basic multiplication method because this takes way too long. Instead, what I'm going to do is I'm going to rewrite this as 1000 plus 25 times 1000 plus 23, and now I can distribute my 1000, so I get 1000 squared plus 23 times 1000, and now I can distribute 25, so I get 25 times 1000 plus 25 times 23. Now 1000 squared is equal to 1 million, so I have 1 million plus 23,000 plus 25,000 plus 25 times 23, which is 575. So now from here, 23,000 plus 25,000 is 48,000, and 48,000 plus 575 is 48,575, and that plus 1 million is 1,048,575. So this is my answer to this problem.